convex programs for specific functions. Let us make the substitution pi j equals to e to the phi j in the system of inequalities above. This makes all the constraints convex except possibly for the ones in 6.12. Whenever each inequality in the set 6.13 also becomes a convex constraint, we get a convex feasibility characterization of the equilibrium prices. Let us first consider what happens to the constraint in 6.12 corresponding to a CES production function fk of z1, z2, z3 until zn, which is equals to a term to the exponent 1 over rho, where the term is the summations of akj times xj to the rho summing for all j, and the rho is between 1 and 0. The corresponding constraint is pi little k, which is less than or equals to ck of pi, which is equals to the term to the 1 over 1 minus sigma, where the term is the summations of akj to the sigma times pi j to the 1 minus sigma, summing for all j, where sigma is equals to 1 over 1 minus rho. We use the standard expression for the cost function corresponding to the CES production function fk, raising both sides to the power 1 minus sigma and denoting that 1 minus sigma is less than 0. This constraint becomes pi little k to the 1 minus sigma is greater than or equals to the term the summations of akj to the sigma times pi j to the 1 minus sigma summing for all j. It is now easy to see that the substitution pi j equals to e to the phi j turns this inequality into a convex constraint. It is also easy to verify using standard formulas for the cost functions that the constraint in 6.12 corresponding to a linear or a Cobb-Douglas production function also becomes convex after the substitution pi j equals to e to the phi j. Thus, we obtain the convex programs characterizing the equilibria in constant returns. Economies where the utility and the production functions are linear, Cobb-Douglas or CES, with rho which is greater than 0. The approach also works for a certain family of nested CES functions. Interestingly, the use of production technologies to simplifying the consumption side plays a key role in obtaining convex programs for pure exchange economies with nested CES utility functions.